So today we're looking at modeling real situations using log functions. So surprisingly, logs can be used for all sorts of real situations whenever we have large exponential growth, whenever one value is much greater than another. For example, in earthquakes, if you have an earthquake that has a Richter scale value of 8 compared to an earthquake with a Richter scale value of 4, the Richter scale value of 8 causes way more devastation than the Richter scale value of 4. The intensity isn't actually 2 times bigger, but the intensity is 10 to the 8 compared to 10 to the 4. So to find the intensity of an earthquake, you raise the Richter scale to the exponent using base 10. So in our first example, we have an earthquake in San Francisco in 1989, which measured 6.9 on the Richter scale, compared to there was an earthquake on the BC coast in 1700 that was 9.0. That's about as big as earthquakes get. About the highest earthquake. So how many times greater was the earthquake in BC compared to the earthquake in San Francisco? So let's calculate what was San Fran's intensity. (10 to the power of 6.9). And BC's intensity is 10 to the power of 9. So if you want to find out how many times bigger, that means we want to know San Fran times how much would give BC's. How many times bigger is San Fran compared to BC? So to solve for how many times bigger it is, we can just take the intensity of BC divided by the intensity of San Fran. The intensity of BC divided by the intensity of San Fran is 125 times bigger. And we can round that up to 126 times stronger. Okay, every time that you go up 1 on the Richter scale, the earthquake gets 10 times stronger. So a 5 to a 6 would be 10 times stronger earthquake. So let's see. If we went from 7 to 9, that would be 10 times 10, so 100 times. This is just a little bit bigger than from 7 to 9. A little bit bigger than 100 times. So now let's find out what would be the magnitude of an earthquake that is 1/4 as intense as the BC coast earthquake. So let's see. We want an earthquake that is 4 times less intense than BC. So we want the BC one to be the stronger one. So the BC one divided by the weak earthquake would be 4. The BC earthquake would be 4 times stronger than the weak earthquake. Does that make sense? Okay, so that the weaker earthquake is 1/4 as intense. So now we just need to solve this for the weak earthquake. So let's multiply 10 to the power of the weak one on both sides. And we can divide both sides by 4. So 10 to the power of the weak earthquake is 10 to the 9 divided by 4. And do you know how you can move that 10 to the other side? Make it the base of a logarithm. And then we'll have the weak earthquake all by itself. Everything goes on the inside of the log. So log of 10 to the 9 over 4 is 8.39, or 8.4. Earthquakes will always have one decimal. 8.4 on the Richter scale. Does that make sense? Let's think about it. If I wanted to be 10 times smaller, then I would need to go from 9 to 8. So 4 times smaller is just a little bit less than 10 times smaller, so about halfway there. Kind of makes sense. Okay, you try example 2. How many times more intense was the 1985 Mexico earthquake with a magnitude of 8.1 compared to the 1966 Turkey earthquake of 6.9? So I put a question mark in the first one, but you can also use an X. So to find out how many times, so I'm just going to say X is the times intensity. I just take the intensity of the first earthquake divided by the intensity of the second earthquake. So the intensity of the first earthquake is a really big number, divided by the intensity of the second earthquake, to get about 16 times. 15.8 times as intense. Does anybody see a shortcut? Maybe a way to do this even faster? Using exponent laws? Subtract the exponents. Right. 10 to the 8.1 divided by 10 to the 6.9 is the same as 10 to the 8.1 minus 6.9. So we can generalize this into a formula that you can write on the top of your page. If you want to find out the number of times intensity, this is 10 to the power of big earthquake minus small earthquake. And this works every time. So we can use that formula now in the very last example. If you want to find the number of times intensity, you can take 10 to the power of the big earthquake minus the small earthquake, because that's the same as dividing those two intensities. So 375 times as intense is 10 to the power of, well, which one's supposed to be big? This one is major, so that means that this one is big. I'm trying to find the minor earthquake. So 7.5 is big, and I'm trying to find the minor earthquake. It's always good to take a guesstimate. I know an earthquake that is 10 times smaller would be 1 less, 6.5. I know an earthquake that's 100 times smaller would be 2 less, 5.5. One that's 1,000 times smaller would be 3 less. So I know my answer should be somewhere between 4.5 and 5.5. Maybe my answer should be about 5. That way, if this is multiple choice, I could just guess.
Unless there's a multiple.
Yes, exactly. Unless there's multiple 5.5 answers. So in order to solve this equation, we need to move the 10 to the other side. To do that, we do log. Okay, when you have an exponent on one side, it can become the base of a logarithm on the other side. Okay, so that's just using the definition of a log. You can also do this by logging both sides. But log 10 of 10 becomes 1. So you get the same answer. So let's see, log of 375 is 2.57. So now I can add x to both sides and subtract 2.57 from both sides. And you get 4.9. Oh, it's about 5. Look at that. Okay. So, for pH, we have a similar thing that happens. I was wrong about suggesting that a pH of 1 would burn through a table. You'd probably need a negative pH to do so. Negative pHs do exist. Generally, pHs range from 0 to 14. 7's in the middle, being water. And as you get up from 7, you're going into more basic or alkaline solutions. And as you go below 7, you're going into more acidic solutions. So essentially, pH also works on a power of 10 scale. So every time that you go up 1 unit on the pH scale, you're getting 10 times more basic. As you go down 1, you're getting 10 times more acidic. So just like we had with the earthquake problems, if you want to know how many times as acidic or basic a solution is, then you just have to take 10 to the power of the big pH minus the smaller pH. So if you want to know how many more times is alkaline a pool with pH of 7 is compared to 7.2, the number of times is 10 to the power of big pH minus small pH. So 10 to the power of big pH minus small pH is about 4 times bigger. And you can also do this backwards. So if you want to find some, you know that you have something that's 2 times as acidic as a human eye, we can put 2 for the number of times, and then we just need 10 to the power of big minus small. So we're looking for something that is more acidic. More acidic is going to be smaller. So that means I'm going to put 7.5 as my larger number because I want that to be my basic solution. Okay, to move the 10 to the other side, you can use base 10. And that brings the exponent down. So moving the small pH to the other side, and moving the log to the right-hand side, I get the small pH is 7.5 minus log 2. Which is 7.2. So you only need to change by 0.3 in order to go double as much. Okay, and you can try the rest of the questions at home.